Students, now we will learn about our third chapter, that is energy. So we know, let's start. We know that all living beings perform certain basic activities, right? For performing these activities we need energy. So where from we get this energy? We get the energy from our food. Some activities like cycling, moving heavy loads need more energy than other activities like reading or singing. We know that. So some activities, and there are some activities which need a huge amount of energy. So in this case we need to use machines. Okay, the burning of petrol, diesel gives us some energy which we use to run locomotive engines, is not it? Okay, so what is actually energy? Energy is actually the ability to do work. So ability to do work is called energy. Okay, so if we consider some examples like when a raised hammer hits a nail placed on a piece of wood, it drives the nail into the wood. We know that. And when the striker hits the stationary carom coin, it sets the carom coin into motion. We know that. So in the above examples, the object acquiring the capability of doing work through different means. Okay, so the object having a capability to do work is said to possess energy. Okay, always remember it. That means the object having a capability to do work is said to possess energy. Okay, so the object which does work, it loses energy, and the object on which the work is done, it gains energy. Okay, how? The object having energy exerts force on another object, and in doing so it transfers the energy to it, is not it? We know that we can apply force when we have sufficient energy, is not it? So the object which does work, it exerts force on another object, is not it? So in doing so it transfers its energy to the object on which the work is done, is not it? So we can say that the definition of energy is the capacity of a body to do work is called energy. Okay, so what is energy? The capacity of a body to do work is called energy. Okay, and the numerical value of work done by a body and the energy is actually same. Okay, if we consider that if 100 joule work is done on moving a body from one place to another, that means to do the work actually, okay, we need the same amount of energy also. So that means if 100 joule of work is done in moving a body from one place to another, then the energy of the body is also same, that means 100 joule, is not it? We know that the numerical value of the work done by the body and the energy is same. Okay, so if the work done is 100 joule, then the energy of the body will be 100 joule. Okay, now the question is, what is work? Okay, actually work is the product of force applied on a body and the displacement, okay, of the body. So actually the definition of work is the work is said to be done only when the applied force causes some displacement of a body in its own direction. That means if we apply a force on a body, then if there is some displacement of the body, then we can say that there is a amount of work done. Okay, so we can say that if you push a wall with all the forces you have and no displacement is caused, then no work is done. We know that. Without displacement no work is done, we know that. So but if you push a table or chair and it gets displaced in the direction of force, then work is done, is not it? So without displacement no work is done. So we can say that when a force causes displacement in its own direction, work is said to be done. And for doing the work, two conditions are there. Number one is there must be a force acting on the body, and number two is the body must move in the direction of applied force. Okay, so this figure implies that we are applying force on this body in this direction. Okay, that means we are applying force on this body in this direction, and this body displaces from the position A to position B, is not it? That means the displacement of this body is in the direction of the applied force. so we can say that work is done, is not it? Because there is a particular displacement, so work is done. Okay, so now we will read about factors determining work. If we consider these two figures, so in the first one, that means figure 1, a trolley being pushed from position A to position B through a distance x, this distance x. Okay, so naturally some force is required to move the trolley through distance x, and hence some work is done. We know that, we have already discussed it, is not it? And if we consider this figure, here the trolley is filled with luggage, is not it? And if we are moving this body, that means if we displace this trolley from the position A to position B, so in this case, that means the displacement is same, but here the amount of force applied is more than in the case of figure 3.2a, is not it? Because here the trolley is filled with luggage, is not it? So to displace this luggage from the position A to position B, we need more force, is not it? So we can say that the work done in the second case is more than the work done in the first case, is not it? So we can say that work done by a body depends upon the force applied. That is, the more the work done, the more is the force applied, is not it? And mathematically we can also say that, because work is actually defined as the product of force and displacement through which force acts, is not it? If we consider the force is F and the displacement is S, then work done W is equals to F into S. Okay, if we consider that the displacement is 0, then S is 0, so W equals to F into 0, that means 0. So we can say that from this mathematical equation also we can say that W equals to F into 0, that means 0. So from this equation also we can say that when the displacement is 0, that means when there is no displacement, then no work is done. If the displacement caused by a force is at right angles to the direction of applied force, then the work done is again 0. So it is actually from W equals to Fs cos theta, so it is not included in your syllabus elaborately, so you will read about that in your higher classes. Okay, so if you consider you are carrying your heavy school bag on your shoulder and standing still, so that means the weight of the school bag is acting vertically downward, and to counter this weight, your shoulder also applying an equal force in the vertically upward direction, is not it? So that you are carrying the bag. Okay, so and the two forces are in opposite direction to each other, is not it? And due to this force, no displacement is caused, so we can say that you are not doing any work. Okay, and if you start working on the flat ground, then the displacement is caused at right angle to the direction of your movement, is not it? So in a way, the displacement does not take place in the direction of the force applied by your shoulder, is not it? The directions are opposite, is not it? So hence no work is done. Okay, but if you start climbing up the stairs or move down the stairs, then what will happen? The displacement takes place in the direction of force, is not it? So in the direction of the displacement and the direction of force is same here, is not it? So we can say that here you are doing some work. Okay, so now units of work. So what is work actually? Work, we know that force into displacement. So the unit of work is equals to unit of force into unit of displacement. So we know that the SI unit of force is Newton and the SI unit of displacement is meter. So Newton into meter will be the SI unit of work, and we can say that it is actually 1 joule. So that means 1 Newton meter is equals to actually 1 joule. So we can say that Newton meter or joule. The SI unit of work is Newton meter or joule. Okay, so what is the SI unit of joule work? The SI unit of work is joule. Okay, so what is the definition of 1 joule? So we know that 1 joule is equals to actually 1 Newton into 1 meter, is not it? So when a force of 1 Newton causes a displacement of 1 meter, okay, then in its direction, then we can say that the work done is actually 1 joule. Okay, so another unit is of energy is calorie. Okay, so what is calorie? So what is the definition of 1 calorie? The amount of heat energy required to raise the temperature of 1 gram of water through 1 degree centigrade is called 1 calorie. And what is kilocalorie? 1 kilocalorie. The amount of heat energy required to raise the temperature of 1 kilogram of water through 1 degree centigrade is called 1 kilocalorie. So what is the relation between kilocalorie and calorie? 1 kilocalorie is equals to 1000 calories. Okay. So now some numerical problems. So the first one is calculate the amount of work done when a force of 30 Newton displaces a body through 25 meter in its own direction. So we know that this we need to find out the work. So what is work? We know that work is equal to force into displacement. Here force is 30 Newton and displacement is 25 meter. So the work will be force into displacement, that means 30 into 25, that means 750 Newton meter, that means joule. So 750 joule. Okay. So second question, a work of 450 joule is done when a force of 15 Newton is applied to a cart. Calculate the distance through which the cart moves. So we know that distance work is equals to force into displacement. So displacement should be work by force, is not it? So work here is 450 and the value of force is 15 Newton. So the displacement should be 450 by 15 Newton, that means 30 meters. Because joule is Newton. So in this third case also, work of 15 joule is done in moving a body through 2 meter in the direction of applied force. Calculate the magnitude of applied force. So we know that force equals W equals to F into S. So F should be W by S, and here the value of work is 15 joule and the displacement is 2 meter. So the force will be 15 by 2, that means 7.5 Newton. Okay.